Using associative classifiers for predictive analysis in healthcare data mining. Introduction. Medical field is a good example where such applications may appear. Consider an example where a physician has to examine a patient. There's a considerable amount of information associated with the patient, example, personal data, medical tests, etc. The association rule mining is one of the most important and well-researched techniques of data mining for descriptive tasks, initially used for market basket analysis. It finds all the rules existing in the transactional database that satisfy some minimum support and minimum confidence constraints. Now, data mining is a process which involves the application of specific algorithms for extracting patterns, models from data. New knowledge may be obtained in the process while eliminating one of the larger costs, data collection. Medical data, for example, often exists in vast quantities in an unstructured format. A new predictive modeling approach known as associative classification. Integrating association mining and classification inside a single system is being discussed as a better alternative for predictive analytics. Some of the classification techniques presented are CBA, CMAR, and CPAR. As discussed in point 10, it achieves higher classification accuracy than traditional classification approaches such as C4.5, FOIL, and RIPPER. According to that, these traditional classifiers are faster, but in many cases, accuracy is not so high. Moreover, many of the rules found by associative classification method cannot be discovered by traditional classification algorithms. Associative classifications. Now, associative classification mining is a promising approach in data mining that utilizes the association rule discovery techniques to construct classification systems. The entire dataset is divided into two parts. 70% data is used as training data, and the remaining 30% is used for testing the accuracy of the classifier. It is a three-step process shown in figure. First, you generate the set of association rules from the training set with certain support and confidence threshold as candidate rules. 2. Pruning the set of discovered rules to weed out the rules that may introduce overfitting. And point 3, classification phase is a step to make a prediction for test data and measure the accuracy of the classifier. Now here we see a patient data as our training data. In step 1, we discover the frequent rule items. Then in step 2, we generate the rules. So a set of class association rules or CARs. And in step 3, we rank and prune the rules to get proper classifiers. And then in step 4, we put up a prediction on the test data. Now, the AC is different from association rule mining. Following are the terminology for AC analogous to association rule mining. Number 1, attribute, which is pair attribute value, is used in place of item. For example, BMI of 40 is an attribute in table 2. Attribute set is equivalent to item set. For example, age old, BP high. Point 3. Support count of attribute AIVI is number of rows that matches attribute in database. Point 4. Support count of attribute set AIVI AMVM is number of rows that matches the attribute set in the database. Now point 5. An attribute AIVI passes the min sub threshold. As you can see in the table, we have a sample database for the heart patient. Point 6. An attribute set AIVI to AMVM passes the min sub threshold if support count AIVI to AJVJ is greater than or equal to the min sub. Now the card rules are of form AIVI to AJVJ, where C class label, where left hand is item set and right hand is class. And a set of rules of all attributes and class labeled together is called the rule attribute. Support count of rule attribute is a number of rows that matches item in the database. Now the advancements in car rule generation. Now an associative classifier based on positive and negative rules. A new associative classifier that takes advantage of negative association rule mining and associative classifiers. These are two relatively new domains of research. This paper extends the concept of positive association rule of the form x to y to x from y and x and y together, with the meaning x is for the presence and dash x is for the absence. Instead of support confidence framework in the association rule generation, the algorithm uses support confidence some measure based on correlation analysis. The items A, B, C, D, E ACE, BD, 4, ADE, 5, ABCD. Now, we see that in step 1, we have to discover the frequent rule items. Step 2, we generate rules, patient data, training data, frequent rules items, set of class associations, cause, class data, and classifies test data. Step 3, we rank and prune. In step 4, the prediction table, the transactional database, for example, RID, age, smoking, etc. The disease, whether they smoke, whether they don't, we take in their information, we take in their age. Now a sample set for a data hard patient. Now an International Journal of Computer Applications says that the correlation coefficient measures the strength of the linear relationship between a pair of two variables. For two variables x and y, it is given by y con yx dash x, where the con of yx represents the covariance of two variables and x stands for standard deviation. Now, temporal associative classifiers. The time is an important aspect of all real-world phenomena. There are many examples of time-ordered data that demand our attention. Example: scientific, medical, dynamic systems, computer network traffic, web logs, market sales transactions, and so on. The monitoring and tracking of real-world events frequently require repeated measurements. That is the volume of dynamic time tag data, and is therefore growing and continuing to grow. Many of the data mining methods we have studied require some modification to handle special temporal relationships. Before, after, during, in summer, whenever X happens, etc. Now, associative classifiers using fuzzy association rule. Now, a discovered rule X to Y reflects association between interval values of data items. Examples are fruit 1 to 5 kgs, so meat 5 to 10 dollars, income $20 to $50, gives age 20 to 30, and so on. Now, this only record belongs to only one of the set as a result of a sharp boundary problem. These are the formulas that we use and some of the tables. Now, we discuss a weighted associative classifier, and then we come to defining support and confidence measure, as well as discussing about weighted support. Finally, we come to the conclusion and future work. In future, these advanced AC can be combined to fulfill the real-life requirements. For example, fuzzy and weighted AC can be combined to give more accurate results, as most of the data in medical is quantitative and weight can be applied to each feature based on the prediction capability. The temporal aspect can be used to improve the prediction for the patients of different age groups. Thank you.